So till now, we have already learned that concept of entropy, the concept of information gain, and as well as the conference of Gini impurity. In previous lectures, we have already learned these things. Now, applying this concept, now we are building the decision tree. How to construct a decision tree. This is the most challenging part and most interesting part in the chapter of decision tree. Now, let's see this thing. So, the same examples here, I also consider the same example that previous I am discussed. Okay, so suppose let's it is our actually data set. This is our actual data set D. This data set is called the D data sets. Let's recall this data set is the D data set. This is the parent data sets, and corresponding from these parent data sets we have partitioned this data set according to the features one. Suppose let's take it's the features one. Suppose let's take this outlook is features 1, temperatures is features 2, humidity is features 3, and wind is features 4, and it is the corresponding output level. Now here this outlook, according to this corresponding to this outlook, we have partitioned this whole data into three parts. This is the in three parts. This is the partitions 1, this is the partitions 2, and this is the partitions 3. Okay, we have already seen these things. Now just write this thing. So we have actually, first what we are doing, we have actually a parent data D, and in this parent data we have seen that in this parent data our positive point means we are calling yes is positive, y plus we call, and no, we denoted this y no point as y minus. We have denoted this thing. Okay, so for this parent data we have seen that our number of positive yes corresponding to the variable y, that is play tennis. We have seen that our yes point, that is y plus and y minus, we have two category, y plus and y minus. And how much point for y plus? Yes, 9 point. Let's see that 1 1 2 3 4 5 6 7 8 9. We have 9 point yes, and rest of the points means total we have 14 points. So the number of total points, the D is 14. So in this point we have yes is equals to 9 point and no is equals to 5 point. And means yes means y plus we have 9 point and y minus we have 5 point. We have 5 point. And we have already calculated that entropy for this data set corresponding to the random variable y means corresponding to the random variable play tennis. We have seen that this entropy value is 0.94. We have already seen this concept. We have already calculated this value, this entropy value. This is the entropy value for the parent data set. This is the parent data D. Okay. Now in next step what we are doing? In the next step we are doing that, and we have divided our whole data sets D in corresponding to the outlook features. Outlook means features 1. I am talking about the features 1. I am dividing in 3 persons using this features 1. Okay, this. Just see this picture. I think this will be clear. So how much category we have for the features outlook? We have 3 category, means sunny, second one is overcast, third one is rainy. Okay, just see this thing: sunny, overcast, rain. And just the partitions of this, just sunny for the sunny data partitions, these like sunny for partitions. If you use the sunny category, then the partition data sets is like this. If we take the overcast of a category, then our partitions is look like this. If we take the rainy category, then our partitions is look like this. Okay. So for sunny, this is for sunny, overcast, rainy. So how many data points? This is y plus y minus. How many data points for the Shani? Just see this. For Shani, we have how many positive points first? Positive point 2 and a negative point no means 3. 2 point for y plus and 3 points for y minus. Now how much value for the overcast? Y plus y minus. If you see how much point for overcast, just see the overcast value. Overcast how much? There have all the pointer yes, all the pointer yes, all the pointer yes. Here means our all the pointer yes and all the 0 are for no. Now see this rainy category. Rainy category. For the features outlook, how much point y plus and how much point for y minus. See first. So for a rainy category, how much point y plus? 1, 2, 3 and 2 for no 2 point. So this will be y plus is 3 and y minus is 2. Okay, we have seen and already seen that how much is actually entropy for this data set. These partitions mean what? These partitions is actually d1, these partitions is actually d1, these partitions is actually d2, these partitions actually d3. Just see this thing, just see this thing, d1, d2, d3, these partitions. So how many entropy, what will be the entropy for the partitions d1? So the entropy we already calculated. I am not calculated again this thing. In yourself calculated it. This will be d2, this will be d3. Why? We can easily calculate it by simple using the entropy formula. And now what is the weighted entropy? How we will calculate the weighted entropy here? So this weighted entropy will be calculated by simple using the weighted value of this. So what will be the weighted value for this data for this d1? So the weighted value for this d1 will be total how much point here have 5 points and out of 14 points here only have 5 points. So total number of points in our parent data is 14. So out of 14 we have only 5 points. Similarly for weighted value, for d2 will be what? 4 by 14. Similarly for weighted value for d3 will be what? 5 by 14. Okay, so this is the sample outlook features, and corresponding to this outlook features, corresponding to the age category for outlook features, we can easily count this value. Okay, so we can if you just calculated its weighted entropy, you can easily got 0.69. okay, you can easily just calculate yourself. And already in previous lecture, one of our previous lecture, we have already calculated this value. So what will be actually the information gain? So what will be the entropy for here? So entropy for the parent node is what? Parent node is 0.94. And the weighted entropy for our child nodes is 0.69. So how much information we have gained for these features? Responding to features 1, how much information we have gained? So the information gain is 0.94 minus 0.69. So I think it will be 0.25. Just calculate it. You can easily find it. 0.25. Okay, 0.25. Now, what will you do? The same thing. We have calculated the information scheme only for the category outlook. That's F1. Now, the same thing we have to do for the temperatures. Now, let's calculate for temperature. So the we have temperature. Now we have temperatures, and corresponding the temperatures, how much category we have for temperature: hot, mild and cool. Hot, mild and cool, we have three category. Hot, we can easily construct it same like this kind of for age. Now we have not again constructed this. Now we have again taken this thing. Now we are doing the same job for the age, if sub child, this child. For the child D1, I am just divide partition this D1 data set according to the temperature first, because we have already considered outlook here. Now we have considered for this data set temperatures. Again we have partition some small portions of the data. Now again we can repeat it for humidity. Then again we have get a small chunk of data. Then again we have repeating for windy. Just we have repeating this thing until we have not reached the last features. So now the main thing is when we have to stop this building this tree. This is the main thing. Let's see it. Let's see two discussions one by one. So we have three features for temperatures: hot, mild and cool. Hot, mild and cool. Okay, we have three features. Now let's count first how much point y plus point for we have for y plus, and how much y minus. Now let's count first how much y have point for y plus, for mild, for y minus, for cool also. Now let's see. So if you just consider the temperature is first, we have considered the temperature is hot. So let's see where is actually hot. Hot they are here actually hot. Here is hot, where here is hot, and here is hot, here is also hot, and where hot. Okay, only we have four data. Instead of in this four, just see this green line. Just see this green line. In this green line we have how much no, 1 2, and how much yes 2. So we have y plus will be 2, similarly y minus will be 2. Now we have seen the mild data. We have seen the mild data. Now let's see mild. This one is mild, this one is mild, and this one is mild, this one is mild, this one is also mild. So how much? 1 2 3 4 5, only 5 point for mild. So in this point how much yes we have? 1 2 3 yes, and 3 yes and 2 no. So we have here yes and 2 no. Okay, yes, and temperature we have 3 yes and 2 no. Is I think I am doing some mistakes. 1 2 3 4 5. Yes, I mistake this line. Okay, so how much yes we have? 1 2 3 4. 4 yes, we have 4 yes. Sorry, we have 4 yes. And 2 no. We have 4 yes and 2 no. Similarly for cool also, just see this thing. Cool, just see the orange color for cool. This is for cool, this is rest of the ones are cool. Cool. Okay, only we have 3 points for cool. 3 or 4. 1 2 3 4 points for cool. So in this 4 point how much yes? 1 2 3 yes and 1 no. 3 yes and 1 no. 3 yes and 1 no. Okay, the same thing, same job will be, we can easily calculate it. Just repeat this same thing for humidity, for humidity and windy, for humidity and windy. Just repeat this thing. If you repeat this thing, humidity, then how much category for we have for humidity? high, normal, high and normal. We have only high and normal. Here we have only high and normal. Okay. In this high and normal, how much point we have? We have y plus, count, y minus. Similarly for y plus we have y minus we have. So how much? If you just calculated the same, just if you just using the same thing, same trick, then you can easily find our y plus value for this one is 3, and for y minus this value is 3, and for normal this is the 6 and this value is 1. Total how much point? 6 here, here 7, here 7, here 6, 6 plus 7, I think I'm doing some mistake. Total it will be 14. 4, 6, 10, 4, 14. Okay, 6, 6, 12, 1, 13. I think they have just calculated it. Then immunity first I am considering high. How much high we have? 1 high, 2 high, 3 high, 4 high, 5 high, 6 high. Total 6 high we have, and total how much we have normal? Sorry, here also we have 1, 2, 3, 4, 5, 6, 7. Total 7 high. Okay, but I am considering a 6. So total we have 7 high. So in this 7 high, how much we have? Yes, 1, 2, 1, 2, 3. We have 3, and rest of the no. No, we have only 4. Okay, 1, 2, 3, no. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay, we have 4 no points. Okay, we have 4 no. Here we have 4 no. Okay, total 6, total 14, I think. Okay, now we have divided the same thing by using the features windy. Now we are dividing the features windy. We are doing the same thing. How much category we have for windy? False and true. True category only. We have only two category, false and true. So in this false category, how much y plus we have and how much y minus we have? Similarly for false, true, false and true also, how much? And so false we have 6, yes, and for 2 no, and true, for true point we have 3 yes and 3 no. The total how much? 8, 6, 14. Okay, so here we can easily compute it here how much its weighted value will be. What? So if you just recall this thing in d1, so its weighted value will be what? Its weighted value for temperature, its weighted value will be for a high, for hot, sorry, for hot its weighted value will be 4 by 14 into h of d1 of y. If we call this thing d1, if this call this thing d1, this is d2, this is d3, then we can easily construct it. This will be 6 by 14 into h of d2 of y. We can easily construct it, this thing. We can easily construct it. Similarly for h case. So now the thing is that we can easily calculate the information gain. So what is the formula for information gain? We can already show the information gain, the formula. Just remind it. Just remind it. Information gain for the category, for the variable y of features f. Suppose let's take about features is f. So it will be the entropy of the parent node, parent data, entropy of the parent data minus entropy of the child data, child nodes. So this parent node child node will be look like this. This is simple called the parent node, and this is simple called the child node. Okay, we have seen this thing. Now what will be the formula for information gain? Now what will be the formula? Information gain for the random variable y of the corresponding features f, which information gain is h of d, means its entropy of the data set is d corresponding to the random variable y, minus I is equals to 1 to k norm of d by d into dh of di of y. This thing is from simple formula of the information gain information. We have already seen this thing. Okay, so first, what from where we have to choose? We have to start our calculation from the parent node. We have to choose this calculation from the parent node, or simple it is the called the root node. This is called the root node. This is called the root node or parent node. This is called the root node or parent node. We have to start this calculation. Okay, so we have seen this. If we just calculated informations, we have to calculate the informations of the outlook. How much informations we have gained here? Just see this 0.25 here we have gained. Similarly, we can easily calculate the information gain for the random variable y for the features. For the feature, second feature is what we have. The second features is we have temperature. Second features we have temperature. Now we can easily calculate this value also. Information gain for the y. Third features means humidity. We can easily calculate it. Information gain for the features what? Windy. We can easily calculate this thing by similar way. And now see this thing, how to extend this how to just draw this by using this simple information skill. How to draw this tree. Okay, let's see. So in first step we have that parent data. This is our parent data. In this parent data we have 9 yes and 5 no, and using simple outlook, we have divided this data d1, d2, d3, that we have already seen this thing. Just see this thing, just I am summarized these things here. Using outlook features we have dividing d1, d2, d3. Just I am reading this thing. And by using the data set what? Outlook. By using simple the data set outlook we have used. Here we simply use the outlook data set. Okay, so here how much we have for the d1 point. For d1 point, how much we have? Yes, just see this our temperature, this one 234032, 23 yes, 2 yes, 3 no. We have 404 yes, 0 no. We have 2 yes, We have 2 yes, I think I'm doing some mistake. We have 3 yes. Okay, for immediate now, for immediate we have 3 yes, 2 no, 3 yes, 2 no. We have 3 yes, 2 no. Okay, this value we have seen. And now we, in the next step we have divided. Now in the next step we have divided these features d1, these features d1 in 3 parts. What this called d11, d12, d13. By using, because we have already taken the outlook features, means f1, we have already taken here f1 features. Now in this step we have taken the f2 features, means temperature features only. Here in this step we have taken only the temperature features, f2 features we have taken only. Similarly, for just one thing, this node, just if you see this thing, so here what is the mp, what is the means what is the entropy here? Just if you just see this thing, what is the entropy here? Entropy of d2 for this random variable y. So here entropy is actually what? Here entropy is 0. So in this case we have not gained any information. So this node is called the pure node. Because here our entropy is 0, this node is called the pure node. Now we have extended these features to using features to the same things also doing here by using sample features, and just same thing, the same thing also we can do. We have to do it. So how much features for the data 3? Just see this d3. First see this data 3. How much features? 3 features for data 3. For features 2 we have corresponding data 3 we have using the features 2 we have divided. This value will be d31, d32, d33. Okay, this value will be this thing. Now the same thing until the end of the features, when we have taken only features 2, this node will be stored. Now we have constructing again this. So for features 3, how much features 3? How much category we have for features 3? We have only 2 category for features 3, no? High and normal, only high and normal, only 2 features, 2 category we have. Now we have divided the same thing for using simple features 3 using the okay features 3. So these will be d111, d112. Similarly here this value will be 3, d121, d122. This thing just we have to build that like that. Similarly for here also using features 3. Just see until the features till now here we have we have to stop this thing when, or no, just see when we have to, when our pure node, we are reaching our pure node, or at the or at the node where there have no data points to divide such kind of features, then only then we have to stop this tree. Okay, just say this thing here, our entropy is 0, means after this stage we have not gained any information, so we have not spread this tree. Now we have here, if in a node we have gained, we have may see that our entropy is totally 0, then we have stopped the making in the tree there. Or if we see that the number of points in this node is only 1, then they have no chance to divide this, they only stop there. Okay, just see this thing. So just continues this thing. Okay, here we have 3 plus 2. Okay, d1, d has to stop. Just see, just like that. Now I'm just redraw this thing. So in the parent node we have just redraw this thing, redraw this picture again. just taken this example, just conclude this example, then I think it will be better. Just conclude this. So in the first parent node we have just write down this thing. We have 9 positive point and 5 negative point, and corresponding using this we have built using this I sample using the features one here. In these features we have show our y plus point how much, 2 plus 3 minus 4 plus 0 minus 4 plus 0 minus, I think yes, and 3 plus 3 minus 3 plus 2 minus, and this node is called the pure node. Now here we have stop to build this decision tree. Now again repeating this process from here. So this process we have repeating here means now we have how much we have category features, temperatures we have, just see this, we have temperatures here, temperature. If you just consider temperature or humidity as you see, so if you just take the 10 temperatures, how much in this if you just suppose let's take here instead of here using here already we have used f1. Now instead of using, if you use the f2, then just see this criteria here. If you use the f2, then f2 just say this data first d1, already taken the outlook, we have not considering outlook cancel. But here if you see you can use the temperatures, this one or this one you can use. So if you just take the humidity, here we have only two category, high or normal, and here we have only three category, hot, mild and cold, hot, mild and cold. Okay, we have three category. Now just consider this category means we have considered here we have three category. If you just consider the f3 category, f3, or if you can consider the f2 category, well, just I am just interested to build this type of tree. So there may be chance to build the various kind of tree. Just I am just interested to calculate this. Now we have considering these wild features. Windy features means what? Windy features means f4. So f4 means if we just take f4 here, so if you just take f4 here, just take f4 high. Okay, no problem, anyone you can easily take. Suppose let's take suppose let's take I am considering the humidity here, f3 features I am considering to construct I am considering here f3 features. If we consider the f3 features, then in this data set how much ES point we have. If you consider the f3 features, there have two possibles, high and normal. F3 features they have two possibles, high and normal, high or it is normal, high of normal. Okay, if we consider the high only, then in high, then we can easily stop it because only high. Just see this thing, if we just taken the high, then only no are coming. If we taken the normal, then only yes is coming, then we can easily build the pure node. So just because of this, so for this we have three negative points. For features high we have, for features high we have 3 negative points and 0 positive points. Here we have 0, here we have 0 negative points and 2 positive points, 0 negative points and 2 positive points in these cases. Okay, so already this is a pure node, then you can stop. This is also a pure node, stop to make this tree, and here also pure node, stop to make this tree. Okay, the same things also, just here, just construct again here. So just build this thing again here. If you just build it, now for building this I am searching that criteria that can easily build the pure node. So just see this thing, just see this data tree. Here we can already build the pure node. Here according to these features, high and normal, you can easily build the pure node. You can easily build the pure node. Now let's see this criteria, D3. Now if you take the OND, so if you just see if you OND is false, just see this thing. If our OND is false, then we can easily build a pure node. If your OND is true, then no. Just see this thing. If you just consider the here these features, OND features means F4 features, then we can easily build a pure node. So this thing will be our advantage to stop the tree to build the to stop the tree as soon as possible. So just if I am here using the what node, I am using here F4 node. F4 features, it will be true or it will be false. If we consider the true, then how much? If we consider the true value, then no is 2 times only, then no value will be only 2 times, and 3 positive 0 times 3. And if you consider the false node, then 3 times each. If you consider the false node, then the yes is only 3 times. Yes is 3 times and no is 0 times. No is 0 times. Sure, we can easily construct your node. Stop to make our decision tree. Here also pure node. Stop to make this decision tree. Okay, I think the how to build this decision tree, just I think just why you will understand why I have to choose these features, why I have choose these features for these nodes F1 here, F3, F4, because as early as possible we build a pure node, it will be advantage for us. Suppose instead of here if we take F2, then this tree may be longer, okay, and then we have increased our time complexity. So in the next lecture, next lecture of this series, we will see how to make our decision tree as small as possible. Okay, so this tree will increase recursively, just this thing. So recursively breaking edge node by using using the information case as the criteria. So first I am using here F1 to divide it, because the information's gain for these features F1, this we have seen 0.25. Now similarly we can easily calculate the information's gain for these features, so according to this information's gain we can build this thing, to reach the pure node as soon as possible, okay, by simple using the information's gain applying here. Okay, if you just starting from F2, then corresponding to F2 you can easily construct the information's gain from this edge nodes, from a subnode, its child node information's gain. Just see this information's gain here. Then for temperatures we can easily calculate it, this thing. This is the simple trick how to. So now the thing is that when we have stopped this, we have stopped to build our decision tree when we reached a pure node. When we reached a pure node, then stop growing the node, then stop growing the tree or node. Okay, no problem. Number two, cannot grow the tree if the number of points of a node is less. If the points of a node is very small, okay, then only you can stop to grow the. Because if we have if a node, if you have small number of points, because this point will maybe have no give any informations, much informations for our data sets. Okay, so in such scenario we cannot grow our, then we can easily stop this. So this kind of, if we suppose like that, if we build a tree like that, suppose if we build a tree like that, this one, here we have stopped it, then for one data set it will informations or gained. So because of this means what, this is a outlier data, this is simply outlier data. We cannot interested to just break this data from here. This means it is a outlier data. Just break this tree from here. Okay, don't need to suppose you have ever 3 points, from here 2 points, here we have 1 point. Don't need to extend this thing because these are the outlier points. Okay, so I think you have understand this thing, this concept. So suppose let's take here we have a number of points here is equals to 10k. Let's take, and here we have only 3 points. Then as an example, let's take you have 3 points, 2 points, then no need to extend this. So the thing that just visualize this thing in another way, we can easily find the hyper parameter concept here. So if we build this thing as depth, so the depth of the tree is depend on that. So the overfitting data means that if I increase the depth of the tree, if we increase the depth of the tree, this means that if we increase the depth of the tree, means we have considering all the points, we have taken as well as outlier points, noisy point, we have considering all the points to build that tree. So this means we have overfit our data. This means that we have overfit our data, our overfitting means we have considering the fewer numbers points also, we have not neglected the outliers, all the points. Our actually we are now building the tree such a way that we have in our training data, we have our training error point is totally 0 in such cases. If we increase the depth of the tree, this means our overfitting of our model is increased. This means that our training error is reduced. Training error is reduced here in such scenario. Okay, and the next thing is that if we just the depth of the tree is small, if we our tape, suppose let's take we have cut this tree from here, we have considering, this means that we have neglected this much informations also, we have not considered this much information. So in such case it is also bad. So if so the depth of the tree, if small, if the depth of the tree is decreased, this means our underfit model, this model is underfitting, we have increased the value of the underfitting model. This means In such scenario, what happen? Our training error is increased. Okay, I think you have so the depth of this depth of the depth, this depth is actually the hyperparameter here. So for a decision tree, so the depth is depth of the tree is called the hyperparameter here. So their depth of the tree is called the hyperparameter. As we see in logistic regressions, lambda is our hyperparameter. Already we have seen this thing. And C hyperparameter for support vector machines. For support vector machines, C for lambda for logistic regressions. Similarly for depth is the hyperparameter for the decision tree classifier. Okay, I think the how this tree is actually built by example using the informations gain concept. I think you have already got this idea. And I think this information theories concept, this concept means entropy concept, informations gain concept, or the Guinea impurity concept. This, I think this thing will be useful for build this decision tree. When and how these informations, these features we have to take to build this tree, this thing will be important. So these informations will help to choose the features, fi. This will help these informations, this entropy, information gain, information Guinea impurity, these things will help to choose the features when we have to choose a features. Suppose here, just I think the motto of this lecture is clear all of you. Why how this decision tree is built. This just so there have many decision tree, but we have to choose among this main decision tree. We have to choose a decision tree that is not as long and as not short. This is the main thing. Actually at the end of the day, we have given a query point, and we have to find its output of this query point. This is our at the end of the day. At the end of the day, we have to do this job. But the main thing is how quickly and how perfectly we have doing this job. This is the main thing in the whole machine learning. So this, for as possible, as quick as to reduce the time, this information, these parameters are help us to choose a right parameter, and when how we have to choose it. Okay.